And I'm going to be going over Unit 10 of our APCSA curriculum, which is recursion. For basics, recursion is a method to simplify a complex problem into a simpler version of the same problem by repeating steps over and over again. So, in programming, more specifically, it's when one writes a method that calls itself to solve a problem, and we call this solving the problem recursively. It's a handy alternative to iteration or writing a lot of loops. Often, recursive code is short and sweet. In this case, we see a method called print stars, which has void return, so it doesn't return anything, and it's a static method, and it has one parameter, which is an integer. So, recursive algorithms have two base cases. The base case is one that's answered directly and basically ends the recursive cycle. So here, and for this function, for this method, we would probably have a precondition that n is greater than 0. So, the base case is if n equals 0, then nothing will be printed and the method will not call itself again. However, if n does not equal 0, let's say the initial parameter is 5, then it'll print the stars and then it'll print a star and then it'll call the method again on n-1, so on 4, and then on 3, and then on 2, and then on 1. And then the final time, when 1 is n and then n-1, then it'll call print stars and 0, and then we'll reach this base case. Recursion can also work well for a variety of algorithms such as sorting or searching. So it can do everything from like merge sort to binary search by breaking up the process into simpler steps. However, if this looks pretty daunting, don't worry. On the AP exam, you'll only need to know the basics of binary insertion and merge sorts. In other words, on the free response questions, you won't have to write that, and it shouldn't show up on the free response at all, really. However, in a multiple choice question, you may have to trace it, or you may have to trace recursive methods. So, in this case, we have a binary search where the search interval is repeatedly divided by half. The method calls itself until it finds the desired input x. So, here, the recursive cases are if the array at a certain index is greater than x, then it'll return the method calling itself with the same parameters, so array left, but however one of them is going to be mid-1, which ensures that it's not going to be an infinite loop. The same way, the else will have return the binary search again, but the mid will be +1. And so this basically ensures that eventually we will have a non-recursive case, we'll have that base case, and this is because we're changing it. So it's another way you can think about it is like writing a while loop, and when you write while loop, you'll always have to have an iterated value. So at the end of a while loop, individuals tend to write I++ or I+2, depends on the parameters and the conditions. But the reason why we write, I++ at the end of a while loop is because if we didn't, it would just keep running forever, and the recursive cases are the same way. So, when you're writing code and you end up, the console where you're writing or what the program that you're writing in ends up quitting, you'll realize maybe you might have written a recursive loop where it just calls itself to infinity and the computer can't handle it.